Hello and good day everyone. So this is the last topic in organic chemistry CHM132, which is chapter 5, amines. So after this lesson you should be able to name the amines according to IUPAC, and then you have to classify the amine, whether it is secondary, primary or tertiary, and briefly describe the properties of amine, compare with alcohol, compare with carboxylic acid, and the last but not least will be to state the synthesis and the reactions of amines. Okay, first and foremost, what is amine? Amine are nitrogen organic compound formed by replacing one or more hydrogen atoms of ammonia. Do you still remember the structure of ammonia? So nitrogen basically can hold up to 3 bonds. Yeah, this is the structure of ammonia. So sorry for the handwriting because I don't have the pen with me now. So if we replace, this is also ammonia. Ammonia is also an amine. And if I replace one of the hydrogen with R group, okay, alkyl group, yeah, R group, so we call it as a primary amine. So this is also amine. Or even I replace another another hydrogen with another R group. Let's say R prime, just to indicate that this R is different from the first R. Okay, so this is also amine. So this is the definitions, the meaning of amine. Yeah? Amines are organic nitrogen compounds formed by replacing one or more hydrogen atoms of ammonia with alkyl group, so R group. And do not confuse amine with amide. Usually I will remind my student not to confuse amine and amide. In the case of amide, you should have nitrogen like this, but it must attach to C double bond O for amide. So please remember it. But of course, if it is no longer NH3, it is no longer ammonia, we call it as amine, and we have specific name for that amine. And that amine can be further classified into primary, secondary, and tertiary. Same goes to amide. You just need to calculate how many carbon attached to the nitrogen. For example, in this group, nitrogen attached to only one carbon, so it is only primary amines. So if you have two carbon attached to nitrogen, so basically you have secondary amine, and if you have all three carbon attached to the nitrogen, we call it as tertiary amines. So primary amine are named using systematic or sometimes common names. So nomenclatures of primary amine, we can see that we have 2-propanamine and 2-aminopropane or 2-propylamine. So usually they will be called like all these three names, but the most common one will be 2-propanamine. Yeah, and I encourage you to name it according to IUPAC, which is 2-propanamine. So you now know that if you have amine as your priority group, functional group, so at the end of the name should be amine. So in this case, you can see that we have cyclohexane here. Don't ever confuse it with benzene, because benzene we have another ring here inside the cyclohexane. But if you have kosong saja ni, this is cyclohexane. So if you have cyclohexane attached to amine, so the name will be cyclohexanamine. Okay, and when you have benzene, okay, nampak tak different tu? Kalau benzene attached to NH2, directly to NH2, we call it as aniline. Nama dia berbeza sikit lah, aniline, nama common dia aniline. And then we have a carbon here, so you can see that we have nitrogen without C double bond O. So dia berbeza dengan amides ya. C double bond O amides, but without C double bond O it will become amine. So this is of course nama parent dia amine, and then you have substituent. Kalau you perasan substituent dekat nitrogen, and substituent tu ada satu saja, satu kepada hydrogen, and another one is to methyl. And then you need to calculate the carbon, the longest carbon available including this amine group. So starting from here 1, 2, 3. So 3 carbon with amine, so you know the name will be propanamine, and then you have one substituent, and don't forget to put nitrogen in front of the substituent because that substituent attached to nitrogen. So N jangan lupa italickan sikit. Kalau you tengok kat sini dia tak italickan, please make it capital letters, N italic, and then you have N methyl, and then propanamine. One ni tak letak pun tak apa, letak pun boleh jugalah. Usually one kita tak letak lah. N methyl propanamine ataupun N methyl 1 propanamine. And jangan lupa sekali lagi, if you have digit, okay, number mesti letak dash ya, dash. Okay, and N pun kena letak dash. Tapi kalau number dengan number, you letak comma. Okay, kalau tak sure yang itu, tolonglah tanya ayah semula. And then we have the second example, like the fourth example, you have two substituent here. Nitrogen, you have two substituent here, and then the longest carbon available will be from here 1 and 2. So you know the name of the parent will be ethanamine, and then you have two substituent, and both are methyl group. And don't forget to mention N2 twice because both positions of metal on the N. So N-dimethyl ethanamine. So in this slide, we want to understand about the boiling point of a compound. So the most important bonding that involve in boiling point usually are intermolecular hydrogen bonding, intramolecular hydrogen bonding, and other forces. But the most important thing, if your compound have one hydrogen bonding or more, usually they will possess higher boiling point. It is really difficult to break down hydrogen bond compared to the other bonds. So for amines, so we have NH usually. So for primary amine, we have 2 hydrogen. If we talk about secondary amine, we have 1 hydrogen, but tertiary amine usually no hydrogen. So the presence of this hydrogen usually will lead to hydrogen bond, and hydrogen bonds will occur between FON with hydrogen, fluorine, oxygen, and nitrogen. So if you compare this hydrogen bond in amine and also hydrogen bond that is in alcohol molecule, of course alcohol molecule has higher boiling point, higher hydrogen ataupun stronger hydrogen bond because oxygen is electronegative than nitrogen. So if you see at this slide, we can compare primary amine, and then we have secondary amine, and then we have the third one is alcohol. So you can see that if we have the same molar mass, we have different boiling point. For primary amine, we have slightly higher boiling point compared to secondary. This is why, this is because steric hindrance, because of the steric hindrance. So if you have steric hindrance, usually it will lower the boiling point. So in this case, you can see that primary amine has higher boiling point than secondary amine, but if you compare with alcohol, definitely alcohol will get higher boiling point compared to even primary and secondary amine. Okay, and then if you compare secondary and tertiary, then tertiary will have lower boiling point because tertiary, first we don't have hydrogen inside the molecule, inside the compound, and the second one is because the steric hindrance, the steric hindrance of the tertiary amine. And then we have secondary amine, which is slightly higher than tertiary amine. And then we have, if you compare with dipropyl ether, it is not even alcohol, it is ether. So of course the boiling point of secondary amine is slightly higher. Yeah. So you can see, you can look closely at this data. So you can see that in this case, amine also capable of doing hydrogen bonding, but it is not as strongly as alcohol molecule because oxygen is more electronegative than nitrogen. So alcohol will get higher hydrogen or stronger hydrogen bond compared to amine. So this amine bond at higher temperature than alkane, of course, compared to alkane, of course, amine will be higher, but it is still lower than alcohol at comparable molar mass. Yeah. So let's see how to prepare amine. There are three type of reactions are used to prepare an amine. The first one is nucleophilic substitution using nitrogen nucleophile. So it means that the nucleophile must have a nitrogen containing compound. And then the second one is reductions of other nitrogen containing functional group. If you are talking about reductions, we need to use reducing agent. I hope you still remember. And C, reductive aminations of aldehyde and ketone. So we can also prepare amine from aldehyde and ketone through reductive amination. The mechanism of amine compound usually occurred through nucleophilic substitution using nitrogen nucleophile SN2. So we have nitrogen containing compound like ammonia attack the carbon and make one leaving group to go out from the compound, and now we have NH3 and R group. So basically we have positive charge, and we have the counterparts, which is X minus, which are the one that leave the groups. And then we have another molecule of NH3, which is ammonia, will remove one proton from the compound and make it neutralize to form amine, and also the counterpart will be ammonium ion. So nucleophilic attack of the nitrogen nucleophile form an ammonium salt, basically through removal of a proton on the nitrogen from the amine. So it is not stable, so we have to withdraw one proton to make it neutral. Now, if you look at this example, the similar mechanism is actually have been done. Don't concern about what will be the side product, because if you follow the mechanism, you will get the side product. And then, for example, in this case, you use different amine, not ammonia. Doesn't matter as long as you have the nucleophilic containing nitrogen compound, attack the carbon through SN2, and then leave the X as the minus, X minus, and then we have the like positive charge, and then ammonium ion. So it will be neutralized by another compound, another molecule of amine. Remove the proton to make it as a neutral amine. So basically you will get secondary amine with like ammonium or ammonia ion. I should skip this slide because I believe that you can actually foresee how the mechanism take place. And same goes to quaternary ammonium salt, but in this time, this time you have the nitrogen attack the carbon, and then you have leaving group, but there's no removal of protons since there's no hydrogen available for this compound. Okay, then we move to reductions of other nitrogen containing functional group. To make it simple, when you have any nitrogen containing compound, it can be reduced to form amine. Okay, for example, amine can be prepared by reductions of the following compound, include nitro compound NO2, nitrile CN, C triple bond N, and primary or secondary or tertiary amides. So all these three compounds containing nitrogen, and it can be reduced to form amine. I repeat, all these three compounds containing nitrogen, nitro, nitrile, and amides. So they can be reduced using any reducing agent to form amines. So, for example, if you have nitro group, it can be reduced by a variety of reducing agent. So, among reducing agents that we have learned before is hydrogen with palladium, or hydrogen maybe with platinum, hydrogen with nickel, iron with HCl, strontium or tin with HCl, lithium aluminum hydride, or sodium borohydride. So if you use any of these reducing agent and then react with any nitro compound such as RNO2, then you will get RNH2 instead. So you will get the formations of amine. So you just need to convert NO2 pada NH2. Okay, other nitrogen containing compound is nitrile. Nitrile are reduced to primary amine, but please use only lithium aluminum hydride. So only lithium aluminum hydride can do the work. So if you have C triple bond N, and then you treat it with a reagent like lithium aluminum hydride with water, you will get C and N to convert to CH2 and H2. So you can see that we still keep the carbon, but the carbon changed to CH2 and nitrogen changed to NH2. Single bond, no longer triple bond. So you are basically preparing amine compound. Okay, look carefully. Now this is my favorite questions, because usually I believe that uh, some past year questions contain this kind of question. For example, we are not going to ask directly from nitrile to amine. Usually we give you some sort of alcohol halide. For example, we give you this methyl bromide, and then this from methyl bromide you can convert it to nitrile group when you treat it with sodium cyanide with SN2. You will convert, you will get you will replace the bromine with CN, yeah, cyano group. Okay, so you will basically get the nitrile, and this nitrile treated with lithium aluminum hydride with water, it will give you amine basically. So please look at the color coded. So CN will replace the Br, and C still keep the carbon number, and C convert to CH2, and nitrogen convert to NH2. So last but not least is reductions of primary, secondary, and tertiary amine. If you have any amine and you reduce it using lithium aluminum hydride or sodium borohydride, those are strong reducing agent. You can basically reduce this amide to amine by changing C double bond O to CH2. So basically we still keep the carbon number. So if you start with ethanamide, you will end with ethanamine. Yeah. So don't change the carbon number. So similar goes to a secondary amide. So when you treat it with reducing agent, you will get uh, like secondary amine. Yeah. So you just change C double bond O kepada CH2. Okay, and yang lain-lain you kekalkan, right? And we have reductive eliminations of aldehyde and ketone, where reductive elimination is a two-step method that convert aldehyde or ketone into primary and secondary amine. So for example, we will start with nucleophilic attack. If you still remember this nucleophilic attack, to make it simple, because we are not going to look at the mechanism in detail here. So to make it simple, you just attach NH3 to this part, to oxygen part, where you need to remove water in the middle. So you just need to extract 2 hydrogen from this NH3 ammonia, and attach the rest to the oxygen place. So you will basically remove H2O and you will get C and H. This is what we call imine. And further reduction, by adding hydrogen, you will get amine at the end of the process. Yeah. So basically you will get amine after reduction process. So let's take a look on the reactions of amine. Okay, first reactions of amine is Hoffman eliminations. Please pay extra attention to these reactions. It is usually come out in your final. Hoffman eliminations. So this is the reactions to convert an amine into alkene. So from amine, we can actually produce alkene through Hoffman elimination. So first thing first, you have to remember the reagents we use in this reaction. So for Hoffman eliminations, if you see, we have this methyl iodide in excess, and then we have silver oxide, AgO2, and a little heat we give to the reactions. So that means we will lose NH3 ammonia here, NH2 and hydrogen in the adjacent carbon, and it will lead to the formations of alkene. I repeat, you need to identify the reagent we use in Hoffman elimination. Usually we use metal iodide in excess, silver oxide and heat, and they will eliminate NH3. NH2 from one carbon and another hydrogen in adjacent carbon. So when you lose this NH3, you will get alkene as the major product, and then you have the byproducts such as water, and then we have a trimethyl amine, and then we have silver iodide. Okay, further detail on the Hofmann elimination is that when we react primary amine with excess methyl iodide, and then we have silver oxide under elevated temperature, and this usually carried out in an organic solvent such as ethanol and acetones. So what happens is that when the reactions of primary amine with methyl iodide leads to the formations of the quaternary ammonium ion, and the silver oxide here act as a base abstracting proton from the amine to form quaternary ammonium ion. And under elevated temperature conditions, for example under refluxing or heating, the quaternary ammonium salt undergo an intramolecular elimination reactions and form and give you some sort of amine and also alkene. Okay, and this alkene, the major consists of major and minor product, and the major product is when it produce anti-side product, which is less substituted alkene will be the major, and minor will be more substituted alkene. And formations of amide, the next one is formations of amide. Primary and secondary amines react with acyl chloride and acid anhydrides to produce amine. So it doesn't matter if you start with acid chloride or acid anhydride. When you treat it with amine, you form amide. This is what we saw in previous chapters. Yeah, both in acyl chloride and acid anhydride. So if you start with acyl chloride, react with amine, any amine, ammonia, secondary, tertiary amine, you will lead to the formations of amide. Yeah, amide, and the byproduct will be HCl. The same goes to here because we just use different kind of amine, different type of amine, secondary amine, primary amine, and tertiary amine. So if you use different kind of amine, it also lead to formations of amide. Okay, and you will get a secondary and tertiary amide. So try not to remember. Try to do the reactions and you will definitely get the answer. This slide shows the amine alkylations where we react amine compound with alkyl halide, and you can see that the R group can be inserted. Nitrogen will attack at the carbon, and then it will be inserted into the compound and replace the hydrogen place. And then we have another hydrogen here that can be replaced by further reacting with alkyl halide. So basically we have all three has been replaced by R group, and we can further react it with alkyl halide to form ammonium salt, quaternary ammonium salt. One important reactions in amine is the formations of diazonium salt from aromatic amine. This is a very good intermediate to form another compound. So what happens is that we treat the aromatic amine, for example aniline, with nitrous acid, where we prepare nitrous acid from sodium nitrate, which is converted to nitrous acid in the presence of acid, which is HCl. And it will result in the loss of H2O. Yeah? So if you react amine with nitrous acid, you will get definitely N triple bond N. This is a very good intermediate to form another compound. Because this N triple bond N will lead to the formations of nitrogen, and it is an excellent leaving group. So starting from diazonium compound, we have a very good leaving group nitrogen, and 2 So we can react it with many compound, with many other compounds such as copper chloride to introduce chlorine. For example, copper bromide if you want to introduce bromine into the aromatic ring. And then we have copper cyanide to form aryl cyanide, copper iodide to like introduce iodide in the compound, or maybe with H2SO4 to produce phenol. Okay, these are among the reactions that diazoxanide salt can do. That particular reactions with diazoxanide salt is called Sand-Meyer reaction. So if you have copper chloride, it transforms diazoxanide salt into aryl chloride. And one of the experiment in the lab experiment amine, we have diazo coupling where we produce azo compound or dye, azo dye, formations of yellow, red, orange dye. So what happens is that we have this diazo compound, and then we react with electron rich aromatic partner with diazoxanide salt like this, and we will produce azo compound. Okay, so you can see here it will only react with electron rich aromatic compound that act as nucleophile. Among the uses of amine is amine are also used in the productions of azo dye. Azo dye are synthetic colorant that contain azo group, and amines are employed as diazo compound in the synthesis of this dye, and they react with aromatic compounds to form azo compound which exhibit a wide range of vibrant colors. So usually azo dyes are extensively used in textile, printing inks, paints and other industry for coloring purpose. And then we have a medicine. Amine is used as analgesic function as painkillers. Certain amines such as primary and secondary amines can exhibit analgesic properties and function as painkiller, and these amines interact with specific receptor in the nervous system, blocking pain signal and providing relief. So analgesic amine include morphine, codeine, and other opioid used for pain management in medical application. And then we have a tetra-ammonium iodide in disinfectant of drinking water. So tetra-ammonium iodide is a quaternary ammonium compound that is commonly used as disinfectant in water treatment process. It is effective against various microorganisms and help in the disinfectance of drinking water by eliminating harmful bacteria, viruses, and other pathogens. And the positive charge on the quaternary ammonium ion interact with negatively charged component of microorganism, disrupting their cellular integrity and preventing their growth. And it can also be used as pest control. Certain amines such as methylamine, ethylamine are utilized in the formulations of insecticide or pesticide. These amines act as active ingredients or key component in this formulation. They can interfere with the nervous system of pests, leading to paralysis or death. So amines are used to control a wide range of pests, including insect, rodent, and other organisms that can cause damage to crops, stock products, or human health. And as fertilizer such as ammonia, amines such as ammonia are essential component in the production of nitrogen-based fertilizer, and ammonia is converted into ammonium salt such as ammonium nitrate or ammonium phosphate, which serve as valuable sources of nitrogen for plants. So nitrogen is a crucial nutrient required for plant growth and development, and amine plays a vital role in providing these essential elements to the plant. And the last but not least is vitamin. Some vitamin, particularly B complex vitamins, contain amine functional group. For example, we have vitamin B3. Niacin contain a pyridine ring with an amine group. So these vitamins are essential for maintaining proper health and functioning of the human body, and they also play vital roles in various biological processes, including energy production, DNA synthesis, and nervous system function. You can try this quiz, naming and classify each compound. Please do at your own pace. Yeah, I believe this is the end of the topic, and this is also the last chapters in CHM132 Organic Chemistry. If you still have any questions, feel free to contact me via email or through WhatsApp. Thank you so much.